All right, we're going to continue talking about solving systems by substitution. In our last video, we looked at what we would do if both equations in the system are in slope-intercept form, in y equals mx plus b form. Today, we're going to be using the same steps we talked about in the last video, the 1 through 5 steps, but we're going to look at systems that look a little bit differently. So here is our first example. I'm not going to go over the steps again. They should already be in your notebook. In fact, instead of calling this example 1, we could call this example 3 as a continuation from our last notes. So this system we're going to solve is going to look like 2x plus y equals 5 and y equals x minus 4. Now, if you recall from our last video, the first step in solving a system using this substitution method is to solve for one variable in at least one equation, if necessary. And in this case, it's not necessary because we do have an equation where we've solved for a variable. So what we're going to do is substitute that equation, that expression, the x plus 4, we're going to take it and put it in for y into the other equation. So let's see what that looks like. So step 2, we were able to skip step 1. We're going to have 2x plus, and instead of writing y, we're going to replace y with x minus 4, and that's going to equal 5. So now we're going to move on to step 3, where we're going to solve for the variable we have. We have x, so we're going to solve for it. Now I'm going to combine my like terms, so I'm going to combine 2x and x to get 3x, and there's nothing to combine 4 with, so I'm just going to bring a minus 4 down in my work. And that's all equal to 5 still. Now to continue solving for x, I'm going to add 4, and I'm going to have 3x equals 9, and then I'm going to divide by 3. So I'm going to find that x is equal to 3 because 9 divided by 3 is 3. Well, now we can move into step 4, where we're going to take this x value we just found, 3, and we're going to substitute it into one of the original equations. And this time I'm going to substitute it into the second equation. So we're going to have y equals 3 for x minus 4. Well, 3 minus 4, that's negative 1. So we found out y equals negative 1. Step 5, we're going to write an ordered pair, an x and a y, and we found those x and y values in step 3 and 4. In step 3, we found that x is 3, and in step 4, we found that y was negative 1. We've got our ordered pair, our solution is there, and we're all done with this example. Let's look at one more. So we'll call this one example 4, and we're going to solve the system x equals 2y minus 4, and the second equation is x plus 8y equals 16. So again, we don't have to do step 1. We don't have to solve for a variable in at least one equation because that's already happened in the first equation. We've got x by itself. So we're going to go straight into step 2, where we substitute that expression into the other equation. So we're going to take the 2y minus 4 and we're going to replace x with it. So we're going to have 2y minus 4 plus 8y equals 16. All we did is we replaced the x in the second equation with what x is equal to in the other equation. So again, I'm going to start solving this, moving into step 3. I'm going to combine any like terms. 2y and 8y, that's going to make 10y. And we're just going to bring our minus 4 down, and that's going to equal 16. Now to continue solving for y, I'm going to add 4. I'm going to get 10y is equal to 20. I'm also going to divide by 10. So I'm going to figure out that y is equal to 2. Now, that's not our answer, even though I've boxed it. We're going to move into our next step. Step 4, we're going to take one of our original equations and put 2 in for y and solve for x. And I'm actually going to take the first equation, x equals 2 times 2, and then I'm going to subtract 4 from it. Well, 2 times 2 is 4, and if I subtract 4 from 4, we're going to find out that x is equal to 0, which that was our goal for step 4. In step 5, we're going to write the ordered pair with an x and a y that we found from steps 3 and 4. Well, in step 4, we figured out that x is 0, and in step 3, we figured out y was 2. So we've got our ordered pair, and now that ordered pair that I've boxed, that is our solution. That is our answer. And that actually is going to wrap up this video in our 3-part video series on solving systems by substitution.